Welcome to our talk about scaling Xtext. My name is Lieven Lemiengre. I'm an engineer at Sigasi, and my co-presenter is Sebastian Zarnekow. He's done a little bit of Xtext in the past, you know. We both work for Sigasi. What is Sigasi? Sigasi is an engineering-centric product company. We're a real product company, so that means we don't do consulting. We actually make a product and we sell that with a software release. What do we make? We make an IDE for hardware designers. So these are people who make digital chips. So actually we make a product for digital hardware design. And how do you make a hardware design? You describe your hardware in a kind of a normal programming language, but then with like extra constructs added to it. These languages that we support are VHDL and System Verilog, and these languages have a very long history, like I think the late 80s, beginning of the 90s, their history started and they're still used today. So we try to make an environment similar to JDT or CDT for these kinds of, for the hardware designers, such that they have all the nice benefits of an IDE. Sigasi has been around for, I think, almost 15 years. Maybe it's already 15. And over the course of our journey, of course, we've grown a bit of a product portfolio. So we have an IDE product called Sigasi Studio, which runs on Eclipse and on VS Code. We have also a command line product. We have an SDK, which allows our product to be embedded in proprietary IDEs. And we are starting some cloud product. It's in development. And of course, I mean, different feature sets depending on licenses and stuff like that. Boring. So Xtext at Sigasi, that started around actually the end of 2010, beginning of 2011, and that was when Xtext 2.0 was still in pre-release. So at that point, we actually already had a technical demo, not based on Xtext, but based on just Antler and regular Eclipse. And we were wondering, like, how do we make a product that could like have the same look and feel as JDT and CDT, but that seemed like quite a daunting task. And actually, Sebastian and Sven kind of convinced us that Xtext could be a very good platform to try to realize this, like, and have a very quick time to market. So the biggest concerns that we had at that time was like, will it fit? Like, because we're taking two big languages with a long history and trying to fit it on top of a platform that was at that time mostly aimed at DSLs. But they convinced us that it would be possible. And well, it was not super easy, but at least it was an interesting journey. We contributed a lot of bug fixes along the way. We did a number of performance improvements to the framework itself, and we definitely helped shape APIs within the Xtext framework. Before we move on, I was supposed to ask,
yes, please.
What is the level of experience with Xtext in this room? So who has written a plugin for Xtext in this room? So let's say that's most people.
Most people.
So you're all kind of familiar with EMF. So if I say resource set, I don't have to explain extra. Yeah. Okay.
Excellent, excellent prerequisites. So. When you think about Xtext, it's considered to be a framework to build domain-specific languages. These usually have a handful of users and depending on your imagination, a probably considerable amount of concepts, but they are not huge. When we are talking about VHDL and System Verilog, we are talking about languages that have standards in the order of 1,200 pages, weird things. So, and we are talking about more than 2 users, more than 5 files per file, and more than 10,000 lines per file. So there are various dimensions on which we had to tackle and still do tackle scalability challenges when implementing that IDE. One of these dimensions is, and these crooked lines are on purpose crooked because I'm not OCD, or I am, I don't know. So we have the number of files per project, so that which roughly makes the size of a project, which often is a considerable pain point when using Xtext. So that is something that we had to address also in the context of the Sigasi IDE products. Then we are talking about file sizes, where it's relevant to think about the maximum file size. How do we handle the outliers? Files with 500,000 lines of code, what happens? We'll see. And we are talking about the average file sizes, because in the context of System Verilog, we are talking about pre-processing, and files easily expand to 90,000 lines per file each. So the average file size is also considerable in our context. That is then a dimension that we also had to address. The syntax and complexity was already teasered, so our E packages easily exceed what is handleable in a EMF tree editor or conveniently editable with Xcore. We are talking about thousands and thousands of E classes there. And it's more than one language that we are talking about. So we have the hardware languages and then configuration languages on top of that have to interact with each other, refer to each other, but should not depend on each other, which is also a challenge. Since we want to make a holistic user experience for the products, all these languages should share a common usability metaphor, and those have to be ensured during the development time as well. And everything is accompanied by the question, how do we make this work across different product lines? How do we make sure that our VS Code offering has feature parity with the Eclipse IDE, as usability-wise, the same standards, and how do we make sure that we don't get lost in the complexity of that? So these are the topics that we want to cover today. When we are talking about the number of files per project, Xtext has a few things to offer out of the box that make it kind of handleable. So we are talking about the clustering builder, the Xtext index, and the EMF standard means by having proxified resources. So when we look at these 3 items, we are easily in a position where Xtext will munch through a bigger project with hundreds and hundreds of files without choking. So what happens in Xtext standard is that the Xtext index is assembled from all your files, where each file is being parsed and processed to create you're familiar with it probably, the resource description. And if we are running out of memory during that process, because it will happily eat through the resources and load all of them as long as it can, when we are reaching low memory barriers, then the clustering builder will make sure that everything is unloaded and the remaining resources are being processed. So that is a mechanism that works based on the fact that EMF does not mandate every resource of your resource graph or model graph needs to be present in memory, because it can proxify resources. So far, so good. What you end up with is, unfortunately, a situation where you pass many resources a couple of times during a single full build. And parsing is usually not the slowest part of the processing, but it's still considerably, it has to be looked at. What you can enable, and what was contributed by Sigasi, you can enable parallel resource loading in Xtext by changing the bindings. So customizing the juice configuration for a language, and make sure that the builder will load resources in parallel on 4 threads, because parsing inherently is single-threaded. We can easily do that, and it scales up nicely depending on number of cores that you have. So that is easily enabled, can be easily enabled. And another thing that can be enabled is resource caching. meaning after the clustering builder discarded some of your resources, it's quite likely that you have to parse them again. And instead of parsing them from source, it's possible to parse them from a binary representation that is persisted on disk or in memory. And that binary deserialization is usually considerably faster than parsing from source. When you go fancy, then you try to customize your validations per resource as well. But here, this is already a treacherous area because EMF is not giving any thread safety measures out of the box. But if you're sure that your validation rules don't perform any side effects, then you can run the validation already in parallel by submitting smaller validation tasks per resource to get faster feedback, basically, speed up the build. What we did at Sigasi was, after some analysis, an approach that we now consider the all-in full parallel processing in Xtext, where we thought, what do we need to do to benefit from modern CPUs? How can we have more parallelism beyond parsing and beyond validation, beyond code generation, which is also available. Code generation, parallel code generation is available in Xtext. It's not strictly relevant in our context, but if you are interested, I think the X-based code generator is per se parallel. So what we wanted to achieve was parallel parsing, linking, and validation. And for that, we had to massage EMF a little bit. Let's say it like this. So there's no such thing as a read-only operation in EMF. Everything is potentially mutating because everything could potentially lazily load another resource, performing a mutation on the resource set. Everything could potentially try to install an adapter. Everything could be a proxy resolution, even if the resource was already possessed. Everything could make a lazily initialized empty list when you navigate a list containment reference. So all these things have been customized in our context. So we use the EMF jet templates to patch the EMF code generation to make sure that there's no such thing as lazy initialization. We made sure that all our adapters are well behaved, don't perform any side effects, are per se thread safe, or can be locked and concurrently read. And we reviewed every single usage of the EMF model from every single service that we implement to make sure that none of these attempt any modifications. Of course, reviewing is only giving us a single point in time. So what we did, we implemented a mechanism to treat the models as effectively immutable by installing tripwire adapters, patching the EMF code to make sure that it throws early exceptions whenever some code path would attempt to trigger a modification after a certain point in time. So this considerable effort led to a situation where we can parse, validate, and link in parallel.
Another issue you'll have if you're dealing with a lot of files in your project is that the performance of your linking becomes crucial. Out of the box, what Xtext provides you is a lazy linking algorithm that's fairly basic, but I believe if you're defining your own DSLs, it's probably fine. But the moment you need a more advanced linking algorithm, for example, a linking algorithm that works with advanced types or type inference or anything that's a little bit more fancy, you probably want to customize how linking happens and move away from the basic lazy linking approach. So at Sigasi, but also for Xbase and Extend, of course, we started applying a batch resolution approach. This means that instead of trying to resolve a single reference in your model, you're basically picking either a subtree or the entire file and you link it in a single go. This is, considerably improves your performance. But you have to do it right. You have to watch out for cyclic dependencies and stuff like that. Those are things that the lazy linking algorithm automatically solves for you, and then these are things you have to think harder about once you start doing batch resolution. Currently, and built on top of the stuff that Sebastian just mentioned, the immutable EMF structures and stuff, and those data structures, we've actually moved away even from batch resolution within Sigasi, and we now have a full parallel approach to our linking. There's not enough time to go into it, but basically, so even resource descriptions are no longer used. It's basically a completely new way of doing linking. Then it's dealing with file sizes, and what I'm talking about here mostly is like, what if you open a really, really big file? What happens with Eclipse? Unfortunately, out of the box, Xtext does nothing, even though it's improved over the years. So in the beginning, there was a lot of quadratic behavior when you were opening big files, and that slowed things down. I believe all of those bugs have been squashed, but I think like opening a file that is like more than, let's say, 10,000 lines in a standard Xtext editor is not going to be a nice experience, at least certainly not in Eclipse, because the Eclipse editor that has blocking behavior. That means that like while you are typing, suddenly your cursor is stuck, and yeah, maybe some characters are going into some kind of buffer, but like you're disconnected from your tool. If you have really big files and these need to be edited, and they are rare, that was actually the situation that is for most of the projects that we have to deal with. So suddenly, like, you have a big project, most files are like, let's say, under 5,000 lines, but then you have like 2 or 3 files that are like 70,000, 80,000, 90,000 lines of code. If people want to edit those files, we offered the lightweight editor. What does that mean? It's basically an editor without the Xtext editor builder attached to it. That means that while you're typing, there's no services that are running directly on the input that has changed. So what you still get into this lightweight editor is like we can still project errors and warnings there. We can still do some basic highlighting, but only based on the lexer, of course. And you can still have like a fairly fluent experience editing these files, but you don't get autocomplete anymore. You don't have navigation anymore. Another thing that you can consider, and this is more for, say you have a smaller file, but it directly depends on one of these big files, that can actually also cause slowdowns, because that big file will have to be traversed a lot while you're editing the small file. If the big file is not open, there's always the option to say, I only have the node model in memory in my editors for the files which are actually open, and for the files that are side-loaded, you basically drop the node model. It kind of depends on, you have to do a number of customizations to do this, but it's a feasible solution. Currently at Sigasi, we've actually moved to a completely concurrent editor. So this is more, let's say, similar to how VS Code works. So the editor is completely disconnected from the UI services, even if, from the compiler services. If the compiler services are struggling to catch up, our editor is no longer affected. And then there's, I mean, it's eventually consistent if you wait long enough. And it's still quite a nice experience in really big files, up to the point where you might ask for, let's say, content assist, like an autocomplete. Then you can get into trouble, because at that point, if you ask for an autocomplete, you need to synchronize with the compiler, and that may take a few seconds before you then get your autocomplete. But it's all around a better solution. So yeah, one thing I didn't mention here is that we also, when we moved to this new editor compiler, instead of the default Xtext behavior is to have a resource set for each editor, and basically each editor lives kind of in its own universe. We've started sharing the resources between all editors, but that also requires quite a bit of dealing with concurrency and threading and nasty things. But it does reduce memory consumption, and it also reduces duplicate work. So basically, what we built is a builder which is actually similar to the regular Xtext builder that basically runs behind the editors. And yeah, if you go the full async approach, we actually had to modify all UI services basically.
Language complexity is something where you don't get a lot of support from the Xtext editor. So whenever you figure there's a problem in your grammar, like the MWE workflow emits errors from ANTRA, there are not many means to track those down. So the best option is literally staring hard at your grammar and enabling a debug grammar feature which emits a reduced version of the same thing that can actually be introspected with AntlerWorks. So there is still an AntlerWorks version somewhere on the internet that is compatible to the Antler version that we are using in Xtext. So it will basically give you visual insights in ambiguities or problems of your grammar. It won't give you any insights into large look-ahead or performance pitfalls in your grammar, but still you get something to work. One approach, if you figure parsing is too slow, is always eliminating all backtracking. And I'm not talking about the backtrack true feature in the workflow, but all the fat arrow predicates in your grammar. These are pitfalls because it's effectively a local backtracking approach, and it will screw up your autocomplete, your error reporting in the editor, as well as the performance in the long run. What you can do to circumvent some of the backtracking ambiguity, I don't know whether this is an ID or a contextual keyword problems, you can enable JFlags as a lexer instead of the Antler lexer, which is more powerful. It has lexer states, so you can put the lexer into a certain, you can give it more context, so to say. And if the disconnect between a sane semantic model and the grammar is too big, what we did and what we have made good experience with is shaping the EMF model into a state where it looks like what you really want to have, and providing these APIs in form of e-operations or adapting the past EMF model to something that you really want to work with in your services. And if you want to go all in, you think about it as a distinction between the concrete syntax model and the abstract syntax model that you really want to have. So this is also the approach that is kind of taken in XBase with the JVM model. So whatever the parser spits out is something that will be transformed into a reasonable model afterwards, where you do no longer depend on the mapping, the auto mapping of concrete of text to model instantiation in the parser. The downside is when you do this, you have to give up on serialization. That's a fact. And of course, if parsing is too slow, avoid parsing. That's something that I already mentioned. So the resource cache that is available in Xtext and can be enabled helps a lot to just read the binary representation of your model instead of the model from text. What we did to handle the complexity of the mismatch between the parse model and what we want to work with, we made an annotation and annotation processor for the Java language, such that we can have more powerful switches. EMF switches are used to traverse models and perform operation based on concrete type. These APIs are huge. I already mentioned that we have hundreds and hundreds of E-classes in our packages. So the regular switch API is just not comfortable to work with for us. What we did instead is a mechanism with these visitor APIs that allows to pass arguments, return values, and therefore eliminates a lot of object allocation and reduces the API to the strictly necessary surface, with the additional benefit that the code size is reduced and more inlining happens at runtime. So these switches are extremely efficient, even though the regular switches are also not slow at all, but more cumbersome to work with in our context. So this is a mechanism that we use a lot to what we call deconstruct the past AST into a model that we want to work with. This is along the lines of what was already said. So instead of passing from text, we store a binary representation in a cache and pull it out from there, assuming Java-lang object, Java-lang string, and everything in between is always necessary when you work with the Java language. It would be nice if those would just be available in a binary form. For Java, it's not a problem because the parser is amazingly fast. For us, there were issues with this, so the binary deserialization gave a nice speed up. And during the parallel linking that Lieven mentioned, we don't need the node model, so whenever we deserialize those resources, when we work with those, we skip the node model and get a nice memory, reduced memory footprint as well. Different languages need to work with each other. This is something that is possible, fairly possible with Xtext. You can do language inheritance, you can refer to the packages of other languages via cross-references, and everything is driven by the index. So usually you don't want to have a language implementation depend on the internals of another language implementation, but just use the API. And the API is basically what's exported into the index. So if you follow the Xtext patterns, you can get into a fairly handleable situation, even with many, many languages that depend on each other. What we strictly recommend is that you use imported E-packages always to have full control over your model. What I already mentioned with the E-operations as well, it's only possible when you have imported E-packages. And that you extract what we call header packages, so abstract representations that do not depend on a concrete language, but are implemented in both concrete languages or in all your concrete languages if they, so like the common API. So it's comparable to the JVM model as well in Xbase. What we want to do, or what we did as well, to ensure that we have a consistent juice setup in all our languages is we change the way the model is generated, the modules are generated and set up. So similar to what you might know from Eclipse UI with the shared module, we also have a shared runtime module, and we want to have common bindings for all languages. So we made a so-called runtime module fragment and IDE module fragment and so on and so forth, where we have a set of default bindings and can also define mandatory bindings that are supposed to be language specific and be configured on each DSL or on each hardware design language. Then we have a custom base module that does a little bit of juice trickery to get the overrides correct. All this is on the slides, that's why I'm skipping a little bit over this. And the trick is now that we do no longer let the runtime module directly inherit from the abstract runtime module, but from our base module, and use juice overrides instead of Java overrides. So we basically munch the multiple inheritance that we get from the interfaces in Java into our setup, and now everything is guaranteed by the Java compiler for us. So it's mandatory to override the missing binding here, and all the other default bindings are automatically available on each of our languages.
So as I mentioned at the beginning, we have a product that we call Sigasi Studio, and it's available on Eclipse and through LSP on VS Code. Unfortunately, when LSP was added to Xtext, I don't think it happened with a lot of thought, and a lot of APIs were duplicated. So if you look at, you'll see that there's a content assist implementation, for example, in Xtext UI, and there's also content assist implementation in Xtext IDE. And actually, very few of the UI services are shared. So if I would start an Xtext plugin right now, and you want to support both, you're kind of in a tricky spot. If you don't plan it correctly, you'll have a lot of duplicated code. If possible, I would just pick one. And if you're low on resources, I would probably write thin wrappers over the Eclipse APIs and just delegate to LSP implementations. And this is actually something we did for a while. Also there's extra things you can do to make sure that, let's say the highlighting is consistent. So we wrote a couple of MWE2 code generators to basically help our VS Code plugin. One of these is, for example, I think, descriptions of all kinds of validations that can be enabled or disabled. Another thing is we generate a text-mate grammar from the Xtext grammar, such that, I mean, if everything is single-sourced, basically. For solving the Eclipse versus LSP issue, in the end, we went all in, and we went for one super API for all services that we basically are re-implementing ourselves. So we're working towards, I put it like that, our own content assist implementation and, for example, semantic highlighting and all of those other things. And these only have a tiny wrapper to work then in Eclipse or in LSP. And then they can choose what they need or what they can bring. But single sourcing, there's actually a big thing about single sourcing that's kind of beneath the surface. And I think at the last EclipseCon, it was also talked about. It's about the Xtext builders, the many builders. So in Eclipse, you already have an Xtext builder that runs on Safe, which is different and even different in semantics than the Xtext builder that runs in your editor. And then you have the incremental builder for LSP, which again also works differently and has different semantics again. And then there's the standalone builder for CLI, which I hope not too many people are using because it's very limited. And we have complex languages, so we have a number of modifications on how these builds should happen. So it was incredibly important for us that we end up with a single builder abstraction that can be reused in all of these places. This is a very big effort. It's still ongoing. We have the right abstraction in place already, but still a few places where we know that we need to make changes. And then, as I already said, at the end, we chose to go for an API that provides the superset. But the intersection is also fine, I think, if your resources are limited. This whole problem is a huge thing, actually, to deal with. And if you're moving from, let's say, an Eclipse plugin and you want to say, I want to go to VS Code, go slowly and incrementally, this felt like eating an elephant. This has started, I think, 4 years ago, and we're still working on it. So Xtext at Sigasi. As you can see, Xtext has kind of dissolved a little bit in Sigasi. There's not that much left of it. The major interfaces are still there, but all implementations, I think by now have been customized or rewritten, and some parts have even been removed. For the stuff that we say, okay, this stuff can never, these services of Xtext can never be used anymore, we've started using Arch unit tests to make sure that these APIs are not used. A big example for that is node model utils. You're probably familiar with it. You cannot use that within Sigasi anymore. And yeah, we often say evolutionary architecture. It's a very slow, many small steps, making it scalable as it is. So the natural question is probably like, why aren't you guys upstreaming these kinds of things? I think we actually, we kind of want to, but it's impossible. Because the moment you start messing with the basic way that Xtext operates with EMF, I don't think you have a mergeable solution anymore. Like we changed the way EMF code generation works, and it's necessary to make it actually work in total. And the Xtext is kind of built around the idea of, okay, you have these models, and now you have these EMF models already, and now you make this small DSL on top of it to make it easier to edit. So it would kind of be going against the mission of Xtext. And also, it's very difficult to deal with the fact that Xtext tries really, really hard to be backwards compatible. Yeah. There's also not that much resources left within the Xtext team, if there is even an Xtext team to be spoken of, to actually absorb big changes. But typically, if we find things that are generally applicable, we've upstreamed these already. Yeah. So thank you for your attention, and if there are questions.
I know that we are between you and the lunch break. Yes, there's a question.
I think it's the obvious question, maybe for other projects trying to do something similar. Would you use Xtext again?
I think with Xtext we managed to get to market with a very small team. Like we were, let's say, 1.5 developer for 4 years or something like that, and we did manage to build a commercial business out of that. I think like that wouldn't have been possible. I don't think Xtext is necessarily fighting us very hard on many of these issues because we hack everything, and it's a gradual path. As I said, evolutionary architecture. But if I were to do it with all the knowledge that I have right now, again, I would probably not use Xtext.
Usually the Xtext framework gives you, or probably any language development framework gives you kind of a blueprint for your language implementation. And you cannot tackle all the problems right from the start. So what we are doing, we are phasing out the biggest pain points first and working towards something that is suitable for us. I think it's a valid approach, especially with a technology that is so heavily customizable and meant to be customized as well. There's another question, yes?
If not Xtext, what else?
It depends. If not Xtext, what else? It depends on your project needs. I could now advertise Langium if you are in a TypeScript ecosystem, Node.js ecosystem. If you're in a Xtext, if you're in an Xtext ecosystem, I would use Xtext. But even if it's regular Eclipse, I would also go for Xtext still. But if you choose a technology and base a business on this, be aware that others built this technology and might pull out of this. This is the same song we sing the entire EclipseCon. When you strategically bet on a technology and do your risk assessment, make sure that you have the know-how in your company, or make sure that the know-how remains wherever it is and is available to you by baking a cake, I don't know what. Help these people to make you happy. Yeah, we will be around. If there's anything you want to ask, something that was inspiring or annoying you, approach us and enjoy the rest of the conference. Thank you so much.